All right, so the purpose of this lesson, or the purpose of the screencast if you are watching at home, is to introduce a new little wrinkle to our notion of solving systems of linear functions, okay? Y'all have been practicing on the homework. We actually just got through discussing several of these. These are all systems of equations, not to insult your intelligence, but because they have what? Equal signs. Very good, right? They've all got equal signs. And, you know, we find these solutions to these systems, and, you know, the solution winds up looking like an ordered pair. That's going to be very different than this system of inequalities, okay? System of inequalities, the solution, okay, I'll just go ahead and tell you to write that down, that the solution will be a region of ordered pairs. Okay? So it won't necessarily just be one and only one ordered pair, but, you know, infinitely many ordered pairs that are all in the same region. Now, the way that we solve this system of linear inequalities out is going to have to be by graphing. Okay? So no choice about it. We're going to have to graph these out. Okay? So we're going to go through and we're going to graph out the first one, and I would suggest putting it in y equals form. Okay? Can you get y by itself relatively easily? All right, what two steps would you guys do? All right, so let's do the top one first. So we're going to subtract 2x. So we got negative 5y less than negative 2x plus 7. And then my next step would be? Awkward silence ensues. Divide by negative 5. Caution! 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 That a boy, flip the sign. So that happens sometimes. We get so used to dealing with equations that we're just like, I'll do whatever I want, and I'll divide by negative anytime I want to. But if it's an inequality, man, we've got to reverse the direction of that inequality. So good. We got 2/5 x minus 7/5. Okay? So Cole, what's my y-intercept for that red line?
Negative 7/5.
And very good. Braden, what's my slope?
2.
Good. So we got our y-intercept identified and our slope identified. We'll graph it out in just a second. We want to do the same thing for the second one. You guys probably already have taken care of this for me. So y greater than or equal to, negative y greater than or equal to negative 3x plus 17. And then divide. So we get y. What do I have to do again? Flip the sign. And then we get dividing by negative 1 just changes those other two signs. So minus 17. Okay? So now we've got to where we feel comfortable graphing both of these lines out. Okay? So we're going to put them on one big fat Cartesian plane, XY plane. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Woo! And we're going to go up 3 into the right 1. Up 3 into the right 1. And you tell me 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. So on and so forth. Should the green line be solid or dotted?
Solid.
Try again.
Solid. Green line.
The green line should definitely be solid.
All right.
Because why? We've got that inclusive inequality. Less than or equal to. So we're going to try and draw ourselves a nice straight line. Passing through those points. And it says y is less than or equal to. Should I shade above or below? Shade below. So we're going to shade below that region right there. Now, truth be told, I've just done something that I don't normally do. In a system of inequalities, I don't normally shade until the end. But I'm going to go ahead and shade right now just to confuse you. And then once the problem's over, I'll say, here's a way to get rid of that confusion. You might not know what I mean right now, but you will in just a minute. Let's graph the red line. Now, it's got a y-intercept of what? Negative 7/5. That's going to be negative 1 2/5, or negative 1.4. So this is a ballpark figure, so we can just go ahead and graph negative 1.4 thereabouts right there. And then as I think Cole or Braden told us a minute ago the slope is 2/5. So we're going to go up 2 and to the right 5. So up 1, 2 to the right 5. Or I could go down 2, 1, 2, 3, 4, 5, and to the left 5. So 1, 2. And you guys tell me, dotted or solid line? Dotted line. Excellent. Should I shade above or below? I should shade above. All right. Now, the way that this, and I tell you what, let me move this out the way. Now we're cooking. All right. So the way that we've got this graphed out, I probably should go ahead and extend my graph just a wee bit, just so you guys can kind of tell what's what. And the red graph, we could take it right there. Okay. So y'all tell me, when we were graphing systems of linear equations, what were we looking for? The point of intersection. Good. Because that point of intersection, its coordinates would make a true statement in not just the first line, but also the second line. Okay? Think graphically about what we've just done. We've just graphed out 2 linear inequalities. Is there a point that you could find that would make a true statement in both inequalities? Where would said point be? The region, if you didn't hear what he said, the region that they shared. Okay, so like, is that up here in region 1? No. Is that down here in region 2? No. Is that over here in region 3? No. Is this over here in region 4? Yeah. I just randomly numbered those. That's not anything official, right? But yeah, this region right up here is the doubly shaded region, the region that's overlapped. Think back to when we were doing inequalities on a number line, right? And we had the word and required an overlap. And we were talking about, well, where does it shaded on? Both. In this region where I've got the little check mark, that's where the ordered pairs exist that make a true statement in both inequalities. All right? Now, I said I did something I don't normally do. I don't normally shade at the beginning. I don't normally shade at the beginning because the graph can sometimes get muddled up. And I would imagine that your graphs probably looked just a little bit kind of complicated, like you had a lot of stuff going on. Here's my recommendation, okay? Just put a little directional arrow pointing towards the region in which you're going to shade. So when you guys told me to shade below the green line and above the red line, like just point and say, hey, I'm going to shade up there. Now my graph is a lot cleaner, and you can kind of tell where are we going to shade both regions. We're going to shade up there, okay? So our solution would include points on the green line, not on the red line, and then anything where? In between. Okay, anything in between. And that's all there is to it. That's how you would graph out a system of inequalities. That's how you would solve a system of inequalities. You're looking for the points that would make a true statement. Okay? Now, let me do something strange. I'm going to number this. This top one, we'll just call it number 1, the inequality, the first inequality. Second, we'll call it number 2. I'm going to put a point on my picture, and I want you guys to tell me if it would give a true statement in number 1 only, if it would give a true statement in number 2 only, if it would give a true statement in numbers 1 and 2, if it would give a true statement in neither 1 nor 2. Okay? So if I put a point up here, for example, is that going to give me a true in number 1? Yeah. All right, remember number 1 was the red one. And number 2 was the green one, right? Green. All right, so that little black dot would give me a true statement in the first one, but not in the second one. Okay? What if I put another dot? What if I put a dot right here? True in neither. What if I put a dot right here? True for number 2, not for number 1. And of course, if I put one right up here, True for both. All right, now let's get a little bit more complicated. What if I put a dot right here in yellow? What if I put a dot right here on this dotted line? Would it give me a true statement for the first one, for number 1?
Yeah. Right now.
No,
The green one.
because it is dotted. That red line is dotted, so we would say no. And then, Sam, you said yes for the green one. You're absolutely right. So we would have to say, is the yellow dot, is the little highlighted dot, is it a solution to this system? No, because although it gave me a true statement in the green one, it did not give me a true statement in the red one. How about this? I'll do a blue dot. What about a little blue dot right here? Would it give me a true statement on the green one?
Yeah.
Yes, because that's what kind of line? A solid line. Would it give me a true statement in the red one?
Yes.
Yes, because it's above, it's where that shaded region is. So the yellow one is not a solution. The blue one, a little highlighted blue dot, is a solution. Aaron.
Why wouldn't it be that just because it started?
All right, good question. So let me think here about a particular number that would work. And we're talking about the red line. So let's just suppose that the coordinates of this are, let's pick something feasible. 20, comma, let's see here, 20, take away the negative 13 over negative 5, 13/5. That's the coordinates of my little yellow point right there. All right, so 20 and comma 13/5. The question is, why wouldn't the yellow give me a true statement? Now, if I plugged the yellow in to this second equation to the green one, you can bet your biscuits it'll give you a true statement, okay? Because 20 times 3 would be 60. We'd have 60 minus 13/5. And of course, that checks out as greater than or equal to 17, without a doubt, okay? Because 13/5 is 2.4. Or 2.6, excuse me, and so it would certainly, 60 minus 2.6 is definitely greater than or equal to 17. But watch what happens when I plug it in. Watch what happens when I plug it into the first equation, to the red line, okay? 20 goes in for x, and 13/5 goes in for y, and we want to see, is that less than 7? All right, 2 times 20 is 40. Negative 5 times 13/5. Cancel the 5s before you multiply. Yeah, negative 13. And what is that? 27? Is that less than 7? No, it most definitely is not. So although, I meant to scratch that up. Although that point makes a true statement in the second one, it definitely does not make a true statement in the first one. Okay, and I might have miscalculated where the coordinates of that point is. Technically, I think what it was supposed to be was 7 on the left and 7 on the right. So I think maybe my value is suspect a little bit. But anyway, Aaron, to answer your question, it wouldn't give you a true statement, and therefore you wouldn't include it as a solution. All right, just for you guys that are not here with me in class, if you're watching at home, I don't know why this screen has frozen up on me. But I do want this homework assignment completed for tonight, so make sure that you're spending an adequate amount of time on it. And then tomorrow when you guys come in class, hear me on this. I'm going to give you a somewhat hefty quiz on this topic. And what I'm going to do is I'm literally just going to pick, I'll pick some random example, and I'll say, hey, here's question number 1 on your quiz tomorrow. Solve that by graphing. That's literally all I'll do. So you guys make sure you put in adequate amount of work on the homework. If you're at home, obviously we didn't go over anything super new today. I won't have inequalities on there tomorrow. It'll just be equations. All right, Alex, it'll just be equations. And you guys can practice some tonight and be ready for it tomorrow. Y'all have any questions? All right, let's call this quits on the screencast. Thank you guys at home for watching.